All right, everybody. Today we're looking at a new way of graphing linear equations. We're going to be looking at point-slope form, but first we're going to do a quick review of slope-intercept form. So first, try this graph. Hopefully what you came up with is that there's a y-intercept of 4. It's a negative slope, so we want it to be going down and to the right or up and to the left. You don't have to make all of these points as long as you plot 2 or 3, that's totally acceptable, and then connect them with a line, hopefully better than I just did. But again, for negative slopes, kind of make sure your line is generally moving down and to the right. So point slope form will generally look like this. Now, I realize that there's an awful lot of info going on here, and it's kind of a big equation, but really, I can kind of summarize it as it's going to be y minus a number equals a number times x minus a number. So it's going to look a little bit similar to slope-intercept form, but there's kind of one extra number in there, okay? And the key is we've kind of labeled what all of those numbers are supposed to be. The number that is in the spot where I have m, that's going to be your slope. So that one right there. And then x1 and y1, the two numbers that are there, they're going to form together to create an ordered pair that's on your graph. Okay, so I got a very easy way of dealing with this without necessarily memorizing it. Okay, so let's check out an example problem. We have a slope of 3/4, but we can't really do anything with that until we have a place to start. All you need is a place on your graph to start, and you can make it. So here's the deal. What you're going to do is this. I find the easiest way to figure out where to start and to figure out how to use this type of equation, this point slope form, is to do the following. Understand that an ordered pair is an x and a y value. What I want you to do is figure out what would I plug in for x to make this whole side turn into a 0, and what would I plug in for y to make this whole side turn into a 0. Try that. Hopefully what you came up with is plugging in a 2 for x would turn that whole side into 0, right? Because we do 2 minus 2 to get 0, times the 3/4 to get 0, and 1 minus 1 would get 0. So we know the point 2, 1 is on our graph because it turns the equation into 0 equals 0. The cool part about this format is that even if I change the slope from something like 3/4 to 1/2 or negative a third or 5, that x equals 2 would still make that side 0 because 0 times anything is 0. So plot your point then 2, 1. That's right here. And then from there, you're going to go up 3, 1, 2, 3, over 1, 2, 3, 4. Up 3, over 1, 2, 3, 4. Okay, so again, I think the easiest way to find the actual point on your graph is to basically figure out what x would make the right side 0, what y would make the left side 0. Okay, there are two additional problems on the back. What I'm going to do is this. I'm going to quickly pause for you, try both of these, and then we're going to do a quick answer reveal. Okay, so for C, the point that I would start at is -3, -2, because that would make both sides 0. -3, -2 is right there. I have a slope of -1/5. So that's going to look something along those lines. Down over here, down here, x equals 6 and y equals 4 would make both sides equal to 0, so I know it's on my graph. So I'm going to plot 6, 4. There's 6, 4. And then I've got a slope of -2. I'm going to make that over 1 so I can do the rise over run, down to over 1. I know that was a quick run through of those two graphs. Hopefully you got it. If not, we're going to be talking about it a little bit more in class.